Welcome to my channel, A Different Angle. This is my channel, and if you have not subscribed and if you like after seeing this video, please subscribe to this. As you can notice in the channel introduction video, I have promised to discuss topics in economics and game theory apart from various other things. So in the new year, I am starting with a lecture series on game theory. One on economic topics will also follow shortly. Uh, the reason for starting this is very simple. This is my humble attempt to reach students and curious audience who do not have access to or a formal access to a teacher. So I hope that you will enjoy learning with me, and I would welcome your comments and suggestions how we can make this better. So let's start our first lecture on game theory. So we will start with one interesting story about game theory and see that what it is about. So this story is taken from one article named Talking Money with Tony Bennett. His hearts in San Francisco, his money in his son's hand. This was published in New York Times in 1999. So this topic tells about that uh, Tony Bennett, he was a musician, and his son Danny was working as his manager. So they met with so Bennett and his son Danny, they met with Robert De Niro, and Robert De Niro asked him, "Hey Tony, there is a movie in which I want you in." Now, Danny Bennett, who was the manager of his father, he thought, okay, a lot of people talk like this, but they never turn up. So I don't know whether to take this seriously or not. So he just forgot about that, and they didn't hear about for 1 year from either Robert De Niro or anyone from that movie company. But interestingly, after 1 year, he received call from the director of the movie, analyze this, and then this was being made with the banner of Warner Brothers. And De Niro was the leader of a crime family who also had some liking for music. Okay, so they needed uh, Bennett's Tony Bennett's song got the word on a string for the final scene of the movie, and the movie was already shot, right? And then they offered $15,000 for this song. Now, when they were discussing, they told Danny Bennett that the movie has been shot. Now he thought, okay, they have shot the entire movie around this particular song because this is very crucial for the final scene, and then they are offering me just a paltry sum of $15,000. Oh no, this is not good. And you know what happened? Warner Brothers ended up giving $200,000. So you see, this is a quantum jump from $15K. So what went wrong here? Does the discussion or the negotiation? Actually, the timing of the negotiation. That's why I have said that this is about the time. So you might have realized that it is a kind of a strategic interaction between individuals where they are talking about a probable exchange. Here, the copyright for the song from Tony Bennett. So, and the crucial thing that happened here was the timing of revealing or negotiating the uh, decision. If they had made this negotiation before starting the movie, then 15,000 could have been a good sum, because if Bennett's ask for more, then they can just switch to some other singer, right? So game theory is about, basically it's about decision, and we all make decisions, right? So the one decision can be that should I start watching the season 5 of Money Heist starting from today? All of you might be knowing that Money Heist is entering its final season, season 5, and it will be aired soon on Netflix. And we also know that this is very addictive, right? So problem is this: if I start watching this, then possibly I would not be able to pay attention to many other things. So should I start this today or not? Or should I start it on, say, Friday night? So this can be one decision problem, a very small one. There can be another decision problem. You woke up in the morning and you realize that you are short on bread. Now it's not a big deal. You can just walk to the neighborhood store and buy some bread. But then problem is this: you also noticed in the that day's newspaper that there are a couple of COVID-19 positive cases in your locality. And of course, the names are not there, so there is probability, positive probability that you may actually run into one of the COVID patients. And despite being having mask and other things, you might actually you are at the risk of infection. So should you actually go for loaf of bread, or should you just manage with whatever you have? There can be a bigger decision problem. Uh, if you remember about the Cold War days between US and USSR, so they used to think, if I detonate this nuclear bomb, what will be the reaction of US? Should I send my submarine to Havana, Cuba, the Cuban Missile Crisis? So all these were decision problems. So this is one thing in common about all these things, that these are decision problem. Be it very individual specific like these, it can be an organization specific, it can be a country specific, it can be if you believe in Avengers and intergalactic life, it can be that kind of decision also. So all these are basically decision problems. The next thing that comes to our mind is that if decision problem can vary from very simple one person decision to intergalactic decision of Avengers, then what are the common components between these? So these common components are three. First is actions. So this is all the alternatives from which the player can choose. So suppose here when we were talking about watching the money heist, the actions can be yes or no. When I was talking about stepping out of for my house for a loaf of bread, again it can be yes, no. When I'm talking about Avengers and others, so you can, if you remember in the Infinity War, the first sequel, so our our Doctor our Doctor Strange looked at millions of possibilities that how they can win the war against Thanos. So that can be one very complex set of actions. Another can be a simple one like yes no. These are actions. One thing you need to understand is this set of actions is given to the player and he cannot change it. He has to decide from that. Now the next building block of this is outcomes. So these outcomes are simply the result or consequence that will result from each of the action. When I said that I should start watching Money Heist from today itself, one of the consequences can be that you may not be able to write the essay that you have to submit on Monday. So that is one of the consequence. Another consequence can be that is to your liking, that you will start enjoying getting utility from Money Heist. Now I took one word, utility. So I need to define what is utility. So this is a hypothetical construct by economists to denote the pleasure or benefit that we receive from doing any action or any good. So now we talked about actions, then we talked about outcomes. Now the final thing that constitutes a decision problem is preferences, and this is very important because this tells us how the player Every individual in a game will be a player. How the player ranks, this set of possible outcomes, and it will start from most desired to least desired, right? So uh, again, going back to money hashed game. So I want to say yes, this is giving me instant utility. So this is the most preferred state. No, this is the least preferred state. So utility that will come from saying yes, it's say X. Utility that comes from saying no is say Z. Then clearly I know that X is greater than Z. Right now I am using the term greater than. We will use a different notice term when we talk specifically about preference relations. So this is that I am ranking all the possible outcomes. So now we can define preference relation. The preference relation greater than equal to describes player's preference, and the notation X greater than, here Y is missing. So X is as good as Y. So it will be read like this: X is at least as good as Y. Okay. So in the next slide, we will talk more about the type of preference relations. You can go to TED Ellis for reading more about these. Okay. So now let's see what are the types of preference relations. So we can see that preference relations can be of three types. First is weak preference relation, second is strict preference relation, and third is indifference relation. So let's see weak preference relation, and for defining this I will use my OneNote so that I can write it here and you can see that what I am writing. This should be more helpful for you. So this is weak preference relation. So how do we define this? We say that X is greater than equal to Y, or we read it like this. It will be read like this. If it is written like this, it will be read as X is at least as good as Y. Okay, or it can be other way. Y is as good as X. So Y is at least as good as X. So both these are weak preference relations. So WPR, just our acronym, nothing serious about here. Then the next is strict preference relation. So what is strict preference relation? Now you should be able to understand strict preference relation. So how we denote this? We say X is greater than Y. You see there is no tilde sign here. There is no as good as. So this is read as X is strictly preferred over Y or better than Y. Strictly preferred over Y, or it can be other way, Y is strictly greater than X, so it will be read as Y is strictly preferred over X. This is strict preference relation, SPR. Like we said here WPR, similarly SPR. Okay, now comes the last one, that is indifference relation. So this is again something you realize that weak preference relation has apart from this strict there was another component. So now we will take that particular component and that will give us indifference relation. Indifference relation. So we write it like this. So this is read as x and y are equally good. So the consumer is indifferent between choosing x or y. Here the consumer was strictly preferring x over y or y over x. But here he is indifferent because they are equally good. So this is about the preference relations, three types of preference relations. Now once we have seen that different types of preference relations, the next thing that comes to our mind is that how to describe a decision maker's preferences. So there are two alternative ways and both are equivalent. First is we can specify each possible pair of action. So like my watching this money hashed, yes is preferred to no, okay, uh, or I can use a payoff function. So what is a payoff function? This is the outcome that will be coming, so the utility attached to that outcome. So they will be equivalent. So like utility of y is strictly greater than utility that results from action no. So both are equivalent way of representing the decision makers preferences. Okay, so let's take an example. Suppose that I have to make a choice between choosing three actions x, y and g, and you prefer x to the other two, which you regard as equivalent. So can you write the payoff function for these preferences? So what you need to do, you need to decide that what is utility from x. This utility is definitely going to be greater than utility from y or utility from g. And utility from y and g is same because you regard that as equivalent. So this is the general structure that we have to follow. Now you can put say like this. Let utility from x is 1 and utility in y and g is 0. We know that 1 is strictly preferred over 0. Or we can alternatively write utility from x is 3 and utility from y and g are 2. We again know that 3 is strictly preferred over 2, right? Or you can put some negative number also if there is disability. Only the order you have to maintain. You have to maintain this particular order. So this is the way we can use payoff function or actions to show a decision maker's preferences. Now let's take one example from Osborne. So this example says about altruistic preferences, that here someone is concerned about others also, a good thing and a rare thing in these days. So person 1 cares both about her income and about person 2's income, and precisely the value she attaches to each unit of her own income is the same as the value she attaches to any 2 units of person 2's income. Okay, so this tells me that how I am going to identify my utility function of this person. How do her preferences order the outcome 1 comma 4, 2 comma 1 and 3 comma 0? So always remember that within the braces when you are writing this, so the first number, the first outcome is for the player 1 and second one is for the player 2. So we have to see that what are the uh, preferences, how she prefers these outcomes, and we have to find a payoff function that is consistent with these preferences. So let's again go back to our OneNote so that we can solve this. So see, it says that there are two individuals. So first utility x comma y, because person one's utility also depends on the income of y. That's why in the utility function of person one, y is also coming, right? Now it says that C cares. Uh, let's go back to this. The value C attaches to each unit of her own income is the same as the value C attaches to any two unit of person's two's income. So simply it says that x plus 1 by 2y. So y's income matters half for her. So she is altruistic, but of course prefers more for her income, right? So this is the payoff function, that utility function that we have to find, right? So this is it. Now what was the question here? Other question: how do her preferences order the outcome 1 comma 4, 2 comma 1 and 3 comma 0? So let's write these outcomes here: 1 comma 4, and then the next one was 2 comma 1 and 3 comma 0. So let's see that what will be the utility of this person one given these outcomes. So utility 1 comma 4 means x has taken a value 1 and y has taken a value 4. So this will be 1 plus, because y matters half for her, so 1 by 2 into 4. So this part will be 2. So this comes out to be 3, right? Utility from 2 comma 1. So here x has taken value 2 while y has taken a value 1 and half of it will matter for her. So this will become 2.5, right? Now the final one is utility from 3 comma 0. So x is 3 here plus 1 by 2 into 0, this will turn up to 0. So this will be 3. Now you see that from these three outcomes, these two are same while this is strictly less. So now I can actually write here like this. This is my separator line. So now we know that utility from 1 comma 4, this person is indifferent in the utility or outcomes 1 comma 4 and outcome 3 comma 0, while she strictly prefers these two over outcome 2 comma 1. So this is the other part of the answer that we needed, right? Now there is another very important point for you to understand is this, that these preferences, they are just conveying ordinal information. So what do you mean by ordinal information? So ordinal. So before understanding ordinal, let's understand cardinal. So by cardinal we mean something that can be actually they are in some particular ratio, like say 2 is 2 times of 1, right? So if I if I love rupees 100, then I love rupees 200 twice as much I love rupees 100. But with ordinal we say that X is preferred over Y, but how much preferred we don't know. So it is like, say, defining beauty, that X is more beautiful than Y, but then how much more beautiful, two times, three times, four times, I don't know. So this is ordinal, right? So the payoff function, the outcomes that come, this is ordinal information. So this is not reflecting any intensity that I like it three times, I like it 2.5 times. No, I like this more than this, and I like this exactly as much I like this. So I can tell an order, but I cannot tell exact difference. Okay. And another thing that you need to understand is this, that suppose that there is a payoff function u that represents a decision maker's preferences, and then there is another payoff function v. This for this function, payoff function v, we have this relation v a, the value from a is strictly greater than value from b. So this will be holding if and if utility from A is strictly greater than utility from B. It means the action A, whether this is taken in payoff function U or in V, this gives me a strictly preferred better utility than action B. Okay, so this V is also decision maker's preferences. So both V and U are similar, they are equivalent payoff functions. Okay, and this will also further move to this, that if u is a decision maker's payoff function or preferences, then any monotonic transformation of this will also represent these preferences. They will be having equivalent preferences. Now we should be able to define our rational preference relation. So we say that our rational preference relation must satisfy two assumptions. One is about this completeness and the other one is about transitivity. So what is completeness? So if we try to define completeness mathematically, then we will say that the preference relation as good as is complete. Any two outcomes x, y in X, they can be ranked by the preference relation, so that either we can say that X is as good as Y or Y is as good as X. So what is the meaning of, what is the significance of this completeness axiom for the general public? See, this by definition rules out the situation of indecisiveness. So even if the number of outcomes are n, our consumer, it assumes, of course, our consumer or individual or player should be able to tell me immediately that this is my most preferred outcome, or I am indifferent between these two outcomes. X is as good as Y for me. So there is no indecisiveness, as the individual will never stand there dumbfounded and cannot decide what he prefers. So that is ruled out here by this axiom. Transitivity is much easier to explain. So this preference relation is transitive. So this means that if there are three outcomes x, y, g in X, then, and if X is as good as Y and Y is as good as G, then X is as good as G. It means I am carrying forward this particular relation that they have in between. So it is simply like saying that, suppose if I remove these things, I make it a strict preference. Suppose that we have three individuals in class, say Ram, Syam and Mohan, and I say that Ram is the tallest one, Syam is at the second point and in the medium in height, and Mohan is the shortest. So it means what I am saying first, Ram is taller than Shyam. Shyam is taller than Mohan. It means this implies that Ram is taller than Mohan. This is transitivity. Okay, so Tredalis mentions one interesting story about Buridan's ass. So what does it tell? It says that suppose that if we put a donkey, how to draw a donkey? Suppose that this is the donkey and he is facing two exactly identical and equidistant stacks of hay. The distance is same, say x. So the donkey becomes confused which one he should go approach to, because they are exactly identical and equidistant. So out of this confusion, it does not eat anything and starves. So this confusion is ruled out by these two, completeness and transitivity. So this is the rational preference relation. Now finally, a rational preference relation, a preference relation that is complete and transitive, is called a rational preference relation. Okay, so this is what we need to start understanding the preference relations. Now we can slowly venture towards the game theory.